is Saturn, the sixth planet from the Sun. It is a gas giant type planet that orbits an average distance of 1.4 billion kilometers, or 886 million miles from the Sun. Being a gas giant, Saturn has no solid surface. Instead, it is composed of churning gases, mostly hydrogen and helium, that would swallow anyone or anything that tried to land here. Any spacecraft attempting to descend into Saturn would face rapidly increasing pressure and temperature, and the deeper it traveled, the more certain its destruction would become. It would be crushed, burned, and torn apart long before reaching the planet's mysterious interior. Saturn is thought to have a slushy core composed of rock, ice, and metallic materials deep beneath its gassy layers. This loose core may take up around 60% of the planet's diameter, and it contains the mass of roughly 55 Earths. At the core, temperatures can reach 11,700 degrees Celsius, or 21,092 degrees Fahrenheit. Saturn formed around 4.5 billion years ago, during the earliest days of the solar system. As the young sun ignited, lighter materials like hydrogen and helium drifted outward, allowing Saturn to grow into a massive world, far from the sun's intense heat. Gravity pulled these materials together, forming a giant sphere of gas that continued to grow over millions of years. Saturn's enormous size and low density reflect this ancient origin, preserving the conditions of the early solar system and its atmosphere. Saturn's internal structure is layered and extreme. The outermost region is a cold, fast-moving atmosphere made of hydrogen and helium. Beneath this lies a deep ocean of liquid hydrogen and helium, created by immense pressure. Deeper still, hydrogen becomes metallic hydrogen in a strange, electronically conductive form of matter that helps generate Saturn's magnetic field. At the center sits the slushy core of rock, ice, and metals, possibly dissolving into the layers above it. These layers blend together under crushing pressure, creating one of the most complex interiors of any planet in the solar system. Saturn's cloud layers are stacked in colorful bands. Ammonia ice forms the bright white upper clouds. Ammonium hydrosulfide creates yellow and brown tones. Water ice clouds lie deeper down, hidden beneath the upper haze. Trace gases like methane, phosphine, and ethane contribute to Saturn's color and atmospheric chemistry. Saturn's atmosphere is home to some of the most dramatic storms in the solar system. The Great White Spot is a superstorm that erupts roughly once per Saturn year, growing to sizes larger than Earth. Jet streams race around the planet at speeds reaching 1,800 kilometers per hour, or 1,118 miles per hour, shaping the cloud bands into long, sweeping patterns. At the North Pole, a six-sided jet stream known as the polar hexagon rotates endlessly, forming one of the most unusual atmospheric structures ever observed on a planet. Saturn's magnetic field is unusually symmetrical and extremely strong. It is nearly perfectly aligned with Saturn's rotation axis, and is around 578 times stronger than Earth's. This magnetic field creates intense radiation belts and influences the behavior of ring particles and nearby moons. It is generated by the metallic hydrogen layer deep inside Saturn, tying together the planet's internal structure and its space environment. Saturn is enormous. With a diameter of 120,536 kilometers, or 74,898 miles, it is about 9 times wider than Earth. Yet Saturn is surprisingly light for its size. Its density is so low that it would float on water. Temperatures at Saturn's cloud tops average minus 140 degrees Celsius, or minus 220 degrees Fahrenheit, while deeper layers become hotter and more extreme. Gravity at Saturn's cloud tops is roughly 1.08 times that of Earth, meaning you would only weigh slightly more here than at home. Saturn rotates rapidly, completing one day in about 10.5 hours, which causes the planet to bulge at the equator and flatten at the poles. It completes one full orbit around the Sun every 29.4 Earth years, giving it long, slow seasons. Saturn's rings are named in the order they were discovered, from A to G. While there are only 7 named, there are thousands of individual ringlets that make up the main rings. Saturn's main visible rings stretch roughly 270,000 kilometers, or 167,770 miles across, yet are incredibly thin, generally about 10 meters, or 33 feet thick, with a maximum thickness of about 100 meters, or 328 feet. They are made of countless icy particles, ranging from tiny grains to mountain-sized pieces. Their bright, reflective ice makes them easily visible, even from Earth. Scientists believe the rings may have formed from shattered moons, torn apart by Saturn's gravity, leftover material from the early solar system, or collisions between icy bodies over millions of years. Their structure is partially shaped by Saturn's moons, which shepherd and sculpt the rings into distinct bands. Saturn has at least 274 confirmed moons, and counting, each with their own unique characteristics. Titan is Saturn's largest moon, bigger than the planet Mercury, with a thick nitrogen atmosphere. Methane lakes that make Titan the only other world in the solar system with stable liquids on its surface. It also has weather systems similar to Earth that help carve its surface. Enceladus hides a global ocean beneath its icy crust. It has geysers that launch water vapor and organic molecules into space, making it one of the most promising places to search for life. Rhea, Iapetus, and Mimas orbit in intricate patterns, shaping Saturn's rings and interacting with its magnetic field. Saturn's moons fall into several families, including inner shepherd moons that guide the rings, mid-range icy moons with varied geology, and outer irregular moons, captured long ago. Together, Saturn and its moons form one of the most diverse and dynamic systems in the solar system. Humanity's understanding of Saturn comes from decades of exploration. Pioneer 11 performed the first flyby in 1979. Voyager 1 and 2 revealed the rings in stunning detail and discovered new moons in the early 1980s. The Cassini-Huygens mission spent 13 years orbiting Saturn, studying its atmosphere, rings, and moons. The Huygens probe landed on Titan, becoming the first spacecraft to touch down on a world in the outer solar system. Cassini's mission transformed Saturn from a distant point of light into a complex system filled with storms, oceans, and mysteries. In about 100 million years, Saturn is expected to lose its iconic rings due to Saturn's intense gravity pulling electronically charged water ice along its magnetic field lines and into the planet through a phenomenon called ring rain. It is estimated that an Olympic-sized swimming pool worth of water material falls from the rings and into Saturn every half hour. As unfortunate as this may be, it shows us that the solar system is constantly changing and evolving over timescales beyond us. I would love to know, have you ever viewed Saturn through a telescope? Let me know in the comments below, or let me know your favorite fact about Saturn. Feel free to hit the like button to help support the channel, and feel free to subscribe if you'd like to join me on more adventures through the solar system and beyond. Until next time.